Yes, students, good morning once again. Today we are going to derive a very important derivation of mean variance and standard deviation for Poisson's distribution. So for Poisson's distribution, we are coming how we are going to derive this mean variance and standard deviation. First, we'll go through very simple. What is Poisson's distribution? Yes, Poisson's distribution is nothing but a limiting form of a binomial distribution in which n will become the number of trials, which is very large, and p we are going to take as the probability of success of events is very small. So you can just go through the graphs and see easily you can understand how this graph is there. It is Poisson's distribution. So you can see these graphs. This curved lines indicates that as this increases, the curve decreases. Means if you take this as m increases, curve, that is height of this curve, decreases, friends. Okay, it's a very important formula, that is Poisson's distribution. P of x is equal to e raised to, here you can see, e raised to minus m into m raised to x divided by x factorial. Please remember this formula, very important, friends. So already we have solved these examples, so this derivation will be very easy, where you can see this x is equal to 1 2 3 4 and so on. That is our random variable. Please remember, x is nothing but random variable, and here you are going to take e is equal to 2.7183. So very simple, it is nothing but the base of natural logarithm. Okay, m is nothing but mean of Poisson's distribution, that is the average number of occurrence of an event, or we just say it is some parameter in the Poisson's distribution, that is the curve, in this curve. So next we see this is a very simple Poisson's distribution is a discrete distribution with a single parameter m. That is what I have said. As m increases, distribution shifts towards right, and whatever the curve is line is there, that is this curved line will go on decreasing. Where the length increases, curve decreases. All the Poisson's distribution is skewed to right. Means they are all bending towards the right side. This is the reason why the Poisson's probability distribution has been called as the probability of distribution of rare events. So please remember this. So now you have to remember here, mean is equal to m and variance is equal to m. So how we are going to derive this? Why it is m and mean is m and variance is m? Yes, immediately we'll just go through our already the basic formulas you know already, students. So we'll just see what is mean. So as you remember, mean is denoted by mu. Please remember this. Okay. Next, now see, already you have come across what is mean is equal to. So a general formula for mean, which is equal to summation x p of x. You can see here. So this x will be what, friend? It will be from 0 to infinity. So please remember this. It will be from 0 to infinity. Okay. So this is our mean. Actually, for all the distribution, we come across this mean. That is our expectation summation, that is x 0 to infinity. X is nothing but random variable, p of x is nothing but probability. So here we are going to take this probability distribution for Poisson's. Please remember this. Means, what is the Poisson's formula? Already you have seen, it is p of x is equal to summation e raised to minus m, and this is m raised to x divided by x factorial. So please substitute these values in this mean. So keep summation as it is. I'm going to take summation from x 0 to infinity. I will keep this same for x. It will be same for x, students. Yes. Okay. It will be same for x. Fine. Then p of x we have to substitute here, summation x 0 to infinity, but you can see we already taken the summation, therefore remains only e raised to minus m raised to x divided by x factorial. Okay, this is clear. Now let's just simplify, substitute x is equal to 0 as usual. You know that after simplification we must get this is equal to m, students. So let us see. So this is equal to, wherever x is there, please substitute 0. So first term will become 0 definitely. Yes. Next we can see plus 1. Now x is 1. So wherever x is there, please substitute 1, students. So this is going to become m raised to 1 divided by 1 factorial. Okay. Next. Okay. Now we'll just simplify, substitute the values now. 1 by 1. Now please substitute 2 as x is equal to 2. So plus, so I'm going to take here 2 into e raised to minus m e raised to minus m as it is. Okay, this is again m square divided by 2 factorial. So please continue like this. So it will be dot 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 dot. So further you can see what remains, students, here. Yes. So it is. You can see in this formula m is common and as well as e raised to minus m is common. So I'll just remove it outside. M e raised to minus m is there. Okay, then I will take this here now. So m e raised to minus m is there. So in this you can, if m is not there and also e raised to minus m is not there, then what remains, friends? Yes, it is only 1 is going to remain here, plus similarly here 1 m is not there, 1 m is there, so what will remain, students? So 2 will remain as it is. E raised to minus m is outside, 1 m is outside. So 1 m will remain divided by, it will be 2 factorial. 2 factorial is nothing but 2 into 1, which is again 2. So you can see 2 and 2 will get cancelled. Okay, so I think 1 factorial will remain here. Fine. So plus, continue like this. X will be now 3. So I'll just write 3. Similarly, I'm going to take here e raised to m is outside. Okay, 1 m is outside. So m cube will be there. So this is going to become, so here you can see you are going to get this as m square divided by, yes, you are going to get here, students, it is 3 factorial. Yes, so I'm going to write here 3 factorial, students. If you further simplify, what happens? 3 factorial, 1 3 will go. So therefore, this is, you are going to get this as 3 factorial. And similarly, if you continue, this is 4 m cube, 4 factorial is there. 4 will get cancelled, so it is 4 into 3. So 3 factorial will remain. Yes. So further, if you simplify, this is equal to m e raised to minus m 1 plus 1 2 is gone, m is remaining, 1 factorial will remain, plus 3 is gone, means 3 into 2 into 1. I can take this as 2 factorial. 1 3 is gone. Here also you can take your students 4 will go. So again m factorial you can take this as 3 into 2 into 1, that is nothing but 3 factorial. So like this it is going to continue, students. Now you can see this value. What is that? Note, please note that. Yes, please note this. Note, that is 1 plus m upon 1 factorial plus m square upon 2 factorial plus m cube upon 3 factorial, so on. This is equal to nothing but e raised to m, students. So please remember, substitute the values now in the above equation. Therefore we get this as e raised to m. So plus and minus will get cancelled. Therefore mean, that is mu, is equal to m. So this is a very simple derivation we have, students, for mean of Poisson's distribution, students. Similarly, we'll go for variance. Yes, I think you have come across what is the formula for variance. So please remember. So how the variance is given here? Very simple. So you should remember, for variance for all the distributions will be, it is summation x 0 to infinity x square p of x minus mu square. So mu square is nothing but mean square, that is m square. That we will substitute later. But first we will just simplify this part, which is very very important. If you simplify this, your work, 50% of the work will finish. Therefore, I am going to take this as summation x 0 to infinity. Yes, it is from 0 to infinity. Then you can take this as x square p of x. I think p of x you already know, friends. So I'm just simplifying this now. And here simple modification I will do. What is that? Instead of taking this x square, I will just substitute like this, plus or minus x. So I'm just going to do minus x plus x, means it is again 0 only. So please remember this. I can just substitute the values here. P of x. I think you have come across what is P of x now here, students. P of x is nothing but, you're going to put the values. So later we'll see. Substitute this, simplify this, students. Yes, this is equal to, okay. So just what will be the simplification? This is equal to summation x 0 to infinity, and if you take common x from this both, so x minus 1 will remain here, plus x will remain, p of x as it is. Simplify further. Yes. So this is equal to summation x 0 to infinity. So this is x minus 1 as it is, p of x I'm going to take here, This is going to become p of x plus summation x 0 to infinity x p of x. So for simplification, I have done taken here this values. I can just simplify this ones. Now you can substitute p of x value. So this is summation x 0 to infinity as it is. X minus 1, keep this as it is. P of x is going to become our exponential distribution, that is e raised to minus m raised to x divided by x factorial. Please keep this in your mind. And then the summation of x is equal to 0 to infinity x p of x we already derived. That is our mean. And that is nothing but we are going to take this as yum. That is mean we have calculated. That is yum. So for Poisson's distribution, yes, definitely. I can just simplify 1 by 1, x is equal to 0, you substitute, x is equal to 1, you substitute. Yes, substitute the values 1 by 1 students. So I'm going to take this as this is equal to, first I will substitute 0. When it is 0, what we get here students? Yes, it will be 0 only. Then plus, when you substitute x is equal to 1, so 1 minus 1 is also 0 here. Therefore 0 plus. Now remains x is equal to 2. Now substitute 2 x wherever x is there. Just substitute 2 value. So this will become now 2 into, yes, 2 minus 1. Yes, it is 1. So please substitute here 1. So next what you will get here, e raised to minus m. Next you can see it is m raised to x. So m raised to 2 divided by 2 factorial. So similarly continue like this. So next will be 3 e raised to minus m cube divided by 3 factorial plus 4 e raised to minus m raised to 4 divided by 4 factorial, and so on. The last term will be m. So that we have taken directly from this value. So this continues till infinity. So what is common here, student? Yes, you can take the common like this. You can simplify 2 into 1, 2 will get cancelled. Here 3 into 2 into 1, so 3 will get cancelled. This will become going to become 2 factorial. Yes, I will just show you. This is 1 factorial, 3 will go. So this will become 2 factorial, 4 will go. This is going to become 3 factorial. Okay, similarly you can see in this, what is common here student in this values? Yes, it is m square e raised to minus m is common. So please remember this, substitute the values now, simplify this. So I'm going to take m square e raised to minus m outside. What is remaining here students? It is 1 plus m upon 1 factorial plus m square upon 2 factorial plus so on. So what is the last term? It is m. We have kept this m as it is. So we'll continue this keeping m as it is. Now already in the from the mean the derivation you have seen this 1 plus m upon 1 factorial plus m square upon 2 factorial is nothing but e raised to m. So please remember this is e raised to m students. Now you substitute the values here. This is e raised to m plus m. So this both will get cancelled. So we get this as m square plus m. Please remember this. Now we'll just substitute in the above equation, that is our variance. V is equal to, that is summation x square p of x, and this is minus m square, that is mean square we have taken, that is mean for Poisson's distribution. Therefore, this value we have already calculated, it is m square plus m minus m square. So minus m square plus m square will get cancelled. Okay, so what is remaining now? We get here only m. Therefore, variance v is equal to, we have calculated is m student. Similarly, what will be the standard deviation student? Standard deviation is sd, which is equal to square root of v, which is equal to, we are going to get this as m. So please remember, so we have derived mean, variance and standard deviation, where mean and variance is equal to m. Yes friends, thank you. If you have any doubt, please put it in the chat box.